Hi, everyone. First of all, I feel like I'm sitting here and I need like a guitar and start singing or something. Thank you all for coming. For those of you who were here yesterday, it's the exact same talk. I hope it goes as well. So I'll be talking a little bit today about the democratization of artificial intelligence and also why I think it's a bit of a fallacy. So I'll be having a bunch of opinions. They're just a one-person opinion, so don't take them too serious. But a little bit about myself, who's talking about this. So I'm a computer geek. I started programming when I was about 12 years old. I've been in tech startups for a while now, and I'm one of the co-founders and CEO of a company called Sourced. And I'm about to put on a huge blob of text. I hope so. I am clickerless. So anyways, while they figure this out, at Sourced, we are obsessed with understanding source code and developers. To me personally, being a software engineer is one of the most creative professions that exists, and it's one of the most important professions that exists today. And when I talk about this, what I really mean is that if you're a software developer, in my opinion, you're not that different than if you're a painter or if you're a writer. And while to some people this sounds counterintuitive, anybody here who's a software engineer might already pick up on this. That if I'm a writer in the English language, doesn't matter if I'm Shakespeare or I'm writing an article for The Guardian, I have the English dictionary full of words, over 300,000 words, and that's my raw material. Right? With those words, up to my own ability and creativity, I can express my ideas, right? And I can pretty much create anything I want. If I'm a painter, I have, my colors on a palette, and I can be like Picasso, or I can be like Monet, or you can try to paint like me, which wouldn't look like much. And you have this raw material. If you're a software engineer, you have programming languages. But programming languages, being abstractions, talking to machines, are also raw material, but they're a lot smaller. Right? While you have hundreds of thousands of words in English language, most programming languages have what we say 60 to 100 tokens. So that's about 40 or 50 reserved keywords, right? Words that you talk to, and the rest are characters and things that allow you to instruct in a programming language. So, great. So no need to read this, but I honestly could not summarize it into bullet points. So this is the only slide with a lot of text. But essentially, if you have this very creative profession, and as a software developer, you have this raw material, and it's up to your own ability and your own creativity and the people you work with to be able to create anything, right? You can be the founders of Google creating a search engine, or you can be here somebody building an app, or you can be writing an operating system. It's really up to your own imagination and your own aptitude and ability. And because of that, I believe software engineers are incredibly creative. But they're one of the creative professions, just like painters in the Renaissance or writers before, that have a special place in history right now. They have a special place in history because for the first time, in the last 20, 30 years, we're starting to see software play such a role that it is actually embedded in almost everything we do. Right? I mean, everybody who's here today at Slush already knows that, but we're seeing technology no longer just on computers and phones and cars, in our refrigerators and our hair dryers. I mean, we keep on moving more and more towards a world that is run by software. My co-founder likes to say is like software is essentially building the new infrastructure, right? Where before we would have, highways that run the world, today we have, virtual ones. But what really kind of struck me as interesting is that there's only 20 million professional software engineers around the entire world. So 20 million software engineers that are writing code and building software that is affecting billions of people. And this is a very small number in my opinion. I believe we have many more writers and even many more painters, and it's a very, very small number of people who are playing an important role because it is up to them, together with the people around them, to build the future. But at the same time, what we're starting to see is that where today there's 20 million software engineers, that number is growing exponentially. For those of you here who have kids, and especially younger kids, quite a few of you might have been thinking about they should be learning a programming language. In many countries, it's becoming part of primary and and secondary education. The UK just gave 1 million microbit computers to every child. So, and this is happening around the world, and it's happening in many places around the world, even at a larger magnitude than it is here in Europe. right? Or in the US, what you see in China and India, when you look at the number of graduates from computer science degrees, it's magnitudes bigger than what we see in other equivalent groups of population in the West. So we have this huge number of expected software developers. But at the end of the day, programming is very young, and building software is very young, right? Compared to writing or compared to painting, which has had centuries and centuries of evolution, programming is still very young, and we keep on not even having a real understanding yet at scale. So I'll give you a few examples. If I'm a developer, I have absolutely no idea how my code compares to all the other code in the world. I don't know. I can understand in my domain a little bit. I can figure out what kind of style I have compared to other people. But if you ask me, say, look, what is a code base that I would be a very good fit with out of the millions of open source projects, I could probably list only a handful, right? I couldn't have any global overview. If I'm a programmer and I'm writing code, the code completion, right, the recommended things that come next is the exact same thing for me as somebody else in the same language. While already on my Apple device or on Android, I have SwiftKey and things that predict based on my own history. There's a lot of this tooling and intelligence around source code that should exist but isn't existing yet. And at Sourced, we download and index every piece of code that's publicly available, and hopefully soon also every private piece of code. So where Google indexes the web, we index source code. And we particularly work in an area called deep learning to build understanding around source code and understanding around developers and projects. So deep learning is essentially the more technical term of what today we often classify in the press as artificial intelligence. AI is an incredibly overhyped term. So I want to start a little bit talking about what do we mean when we talk about AI. So there's about 3 types of artificial intelligence that people talk about. There is, let me start from the bottom. We have artificial superintelligence. This is essentially this moment in history where we might be one day that computers and technology, well, this feels very pumping, where computers and technology and AI really surpasses us as humanity. Right? This is what a lot of people are scared of. Philosophers like Nick Bostrom, they say, look, one day we'll be at this point where there is this superintelligence, and as humans we become irrelevant. Then there's a little bit of a level down, which is about artificial general intelligence, AGI, which is essentially saying, look, there will be a point where artificial intelligence can do everything a human can in the exact same way with the same type of understanding and potentially a similar type of consciousness. Right? We're getting artificial intelligence to the level of humans. On those last 2, we are nowhere near there today, in my opinion. And it's also a bit the general opinion that we're not close to that yet. But we have become incredibly good at artificial narrow intelligence, ANI. So today when you speak to Siri or you speak to Google Voice and it recognizes your terms and it can interpret your accent, that is based on deep learning, on neural networks. That's essentially a narrow intelligence. It solves one specific task and problem. Where Google DeepMind can now beat the world's best Go player, which is a game that essentially has so many possibilities that no regular computational set of instructions can win it. That is, again, artificial narrow intelligence. And the goal, or at least the hope of a lot of people, is that we can move from this narrow intelligence, right, technology that can solve specific tasks, to technology that is general, right, hence the general intelligence that can solve many tasks. But we're still very early on in that. At Sourced, we care about building ANI that understands source code and understands developers. And the reason we do so is that we want to be in a position where we can tell you as a developer, based on your code, what team should you join based on their code. Right? It really is around building this understanding. And there's a talk later today by one of our senior machine learning engineers which goes more in depth on this. So if anybody's interested, definitely have a look. It's at 3:30. But I'll go and stop talking about Sourced and talk a little bit more what I consider this democratization of artificial intelligence. So when we talk about AI before that, we talk about neural networks, right? Deep learning, neural networks, reinforcement learning, machine learning. Many of these things are terms that are related to each other or subsets of each other. And in most cases today, what underlies most of the technology that recognizes photos, that recognizes your voice, are neural networks. They're very loosely modeled after the way neurons fire in our brain. But the most important thing to understand from them is that as a developer, you're not writing instructions. You're not saying, if I see this, then do this, or else do Y. But you're actually training systems on data. You're showing it data, you're showing it examples, in many cases millions of examples, and it builds an understanding of the pattern of what's inside that so that it can recognize it or act upon it similar as we can as humans. And in some tasks today, computer vision, for instance, like recognizing breeds of dogs or recognizing things in images or driverless cars, the AI for computer vision is far ahead even what we can do as humans ourselves, right? Just because machines can process more data. So one of the things that I found very fascinating is kind of the playing field, right? So internet was a new technology that revolutionized the world. In my opinion, deep learning or AI is similar. But at the end of the day, when you have a technology that's having such an impact in the world, you want it to be on a level playing field. You want to be able that you yourself, as a researcher or as a student, can get access to the same knowledge that the top researchers have in Google or have in Facebook. And I'll be talking a little bit today about how I believe there is some democratization and some equality, but we're not fully there yet. So the reason I care about this is that I work today as a business guy, pretty much. I get to spend a lot of time in engineering teams. I love programming in my free time, but I have no background, no PhD in deep learning or in machine learning, and I had to kind of educate myself from scratch. And I was able to do so because of a few different things that are out there. And if anybody here is interested in deep learning and AI, this is kind of the starting point. So Archive is a website. It's called a preprint server. It's essentially where researchers of many fields put their research papers before they submit them to journals. Right? So you can read all the research right when it's actually put out there, instead of waiting for it to be accepted in a journal 9 months later, or never accepted in many cases. What's interesting about this is that in the community of deep learning, a lot of researchers have made the habit that you put your research here first, because if it's there first, you can kind of claim the crown, right? You're the first person who did it. And this is very interesting because all of a sudden, which we don't see in many, many areas of science, research is open, everybody can read it, and it's straight away there the moment somebody has figured something out. When I started looking into this area, there was maybe 8 or 10 research papers a week. Today we have hundreds of research papers from all over the world in the area of artificial intelligence, across many different spectrums, there. And I can read it, you can read it, and this is, for me, it's a very beautiful thing, right? And this happens from inside companies like Google that are putting their research there, and it happens equally with, a student in China who has figured something out and wrote up a paper. Then we have libraries, essentially, frameworks of technology that allow us to get access or a higher abstraction of running neural nets and being able to actually interact with the data. The most popular one in the world today is actually one by Google called TensorFlow. Probably the reason it's most popular, in my opinion, is as the first library that was so well documented that a lot of people who didn't have the background in the field or in the PhD were able to relatively quickly get set up and get started with things. So there's some opinions if it's the best library or not. If anyone wants to know, I have someone as well. But it's definitely the one that has gained the most popularity. And so today, there's a lot of new researchers out there using these libraries. And they're open source, anybody can work on them, edit them, and it's in the advantage of Google itself, just like it's in the advantage of Facebook, to keep on pushing this research out there and making this code open source. Because at the end of the day, if you have tons of machine learning engineers around the world who are able to use the same technology you're using inside your company, makes it a lot better to be able to people to hire, people to move between different projects, and research in general to become more equal. Then there's GitHub. GitHub has become synonymous with being a developer these days. It's where developers host and collaborate on their code bases, on their projects. And what's started happening in the deep learning community in the last few years is that people weren't just sharing the research. They weren't just showing these are the experimental results and these are the conclusions. They were also starting to share the code behind it. And this allowed two things. This allowed people to reproduce results. And anybody who works in science understands how important it is from research to be able to reproduce people's results, to see if it really is the case that it's true. But it also allows people to build on top of it and adapt it. And there's a lot of companies today that are, a handful or less, or maybe 1 or 2 machine learning engineers that are building on top of the code of other people that's open source. And we cannot underestimate today how much people are building on top of each other's research. But what's interesting once you start building on top of each other's research is you're just accelerating innovation at a much faster curve all around the world. And then you have Twitter. So Twitter, and I really don't know why, for some reason became the hub for discussions around deep learning research. most people in the field are tweeting about their research, are asking questions, they're filtering down to hundreds of research papers that are coming out every week. You're able to just start following people and getting a more, better view of what you should focus on. And this is quite interesting. It's an incredibly tight-knit network of people, some who are students, some who are working at big companies, some people who are in startups, that are able to get access to each other and ask questions. So kind of this combination of all of these things is enabling equal access to state-of-the-art research, no matter who you are or where you work. And that sounds really good, but there's a flip side to it as well, in my opinion. But I'll get back to it a little bit later. So there's another trend that has allowed deep learning and has allowed kind of artificial intelligence, as the press likes to call it, to get to a point where it wasn't before in history, and is that the CPU, right, the central processing unit of your computer, which is still responsible for processing most data and applications and things that are running your computer, is relatively slow. But the graphics cards, the thing that is in your PlayStation or in your gaming machine, are incredibly fast at what's called floating point operations, essentially the ability to do things like matrix multiplication and other type of mathematical operations much, much faster than a CPU is. And at the end of the day, neural networks are mathematical operations. There are a lot of dealing with matrices, doing a lot of multiplications, a lot of essentially formulas, loss functions on top of it. And GPUs have become so fast and initially were pushed primarily for the demands of graphics. Right? If you've seen video games improve in graphics from your PlayStation 1 to your PlayStation 4, that is primarily enabled not just by the software, but by the fact that these chips keeps on getting faster. What's interesting, today we're at the point where the magnitudes of difference that GPUs make in terms of how fast they can process leave CPUs just out in the water. And what was interesting, that this trend, which had nothing to do with deep learning or with AI, but it was purely in graphics and gaming, all of a sudden enabled researchers around 2012 to start seeing, hey, the things that we always wanted to do. Because the research in deep learning is as old as since the 80s, right? Since almost the beginning of computer science, but now the processing power was there. And that's super interesting. And at the same time, there's data. There's a lot of data in the world, right? I mean, I was super amazed. The other day I was on Amazon buying a USB drive, and about 128 gigabyte USD drive for like $20. I mean, that for me is just mind-blowing how cheap storage has become, but it also is a function of how much data there is in the world, right? I was just talking to one of the engineers at Google, and they're like, our search index is probably in the exabyte size. That's a lot of data. I mean, that you can blanket the world in several layers of paper of data, you won't even get to an exabyte yet. So what I found really interesting is that, there's more and more data coming out there, and if you mention what I mentioned earlier around neural nets, they are learning from examples. They're learning from data. Most of learning is still what we call supervised learning, showing essentially a piece of data and what you believe the output or the input should be. And because of that, we're in this world where there's a lot of data, but the reality also is, and this is kind of the flip side to democratization, a lot of that data is with companies like Google, is with Facebook, is with Tesla, is with Amazon, and it is becoming proprietary. And anybody who works in AI or in deep learning, whatever you want to call it, talks about that the real value is in your data. So even though we have this equal world of research and with this equal world of opportunity, the data gets centralized. And that, in my opinion, gets a little bit scary because we built the internet to be decentralized. We like to think about technology to get access to everyone. But at the same time, the companies that are really going to be able to leverage this are the companies who have access to your data. And this is a little bit a dual side of a coin. Right? It's incredibly valuable that it exists, but it's getting very, very centralized. And as data grows in size, computation matters more. It's no longer that you need 1 or 2 GPUs, you need hundreds of GPUs, you need thousands of GPUs to be able to process data at the scale of Google or Baidu or any of these companies. But when all of a sudden, to have neural networks work well, you need a lot of data and you need a lot of computational power, the playing field is no longer that democratic, right? It is not that equal. You're no longer the guy in the basement who has access to the best research, but you might not have the ability to actually put your ideas in place at scale. In our case, as a small startup, we're very lucky because we work on top of code. Code happens to be one of the data sets that is widely publicly available to everyone. But if you want to work on top of image recognition, there's no company better in the world that has labeled data, of what is what image, is Google, for instance, right? Or Baidu. If you want to work on top of translation, you better be running, Google Translate or any of these things. So it's very dual, in my opinion. And at the same time, what we see happening with hardware is that GPUs were great, but all of a sudden a lot of companies started realizing that these GPUs were built for graphics. What if we start building chips that are very much specialized to be very, very good at deep learning and very, very good at running neural networks? So Google built TensorFlow processing units, TPUs. Right now, Microsoft has deployed millions of what are essentially FPGAs. They're not as fast, but they're chips that can be continuously reprogrammed for specific tasks. So on one hand, we have access to this infrastructure, right? If we use Google Cloud, you have access to TPUs. If you use Microsoft servers, you get hopefully access one day to the FPGAs and all of these kind of things. But at the same time, you're centralizing computational power. So we're getting this duality, right? We're able to do things because the cloud exists, and that's incredibly, advantageous. But you might be as a company, and we are, for instance, we'll soon be investing in hundreds of GPUs that we're buying, but they might not ever be at the speed that some of the proprietary technologies that other companies have. So you're really in this place where it goes back and forth, right? And it's interesting, and you see some of these advantages in other markets. You see Apple has an advantage over everyone else because it is able to control what it manufactures years before anyone else gets access to it. So this is for me kind of this, I'm a big fan of Google, I'm a big fan of the cloud platform, a lot of things that are enabled, but it really is this kind of dual world where we have centralized data, centralized computation power, but open research. Where's that going to end up? I really don't know yet. Right? And then there's a company that plays a very important role in this space. It's a company I've loved for years, and it's NVIDIA. Right? NVIDIA, we know, is the company that built the graphics cards, and if you're a gamer, you definitely know NVIDIA very well. But all of a sudden, their chips have become the preferred GPUs for people in deep learning. AMD is probably super upset, and Intel is kind of shitting themselves as well. But NVIDIA is really, really winning in this space. And they're one of the companies that has now in the position to be able to actually level the playing field again, right? Building specialized chips for deep learning. And I think it's going to be very curious to see what they're coming out. But in my opinion, within the next 10 years, graphics will probably be a smaller part of their business than what actually deep learning is. So this is kind of what it comes down to, right? We started the internet as a decentralized network. I remember being very young, getting access to my first computer and ending up on hundreds of different websites and going into bulletin boards and playing text-based games that were hosted on different servers. But today I go on the internet or I see my brother or my mother, we spend time on the same 6 or 7 websites. Right? It is no longer that decentralized. We might install 300 applications on our phone, but we use 5 or 6. So we really are in this world where technology is supposed to make everything democratic, but then we spend all of our time on a very, very small part of the web or a very small part of technology. The same thing seems to be happening with access to research in deep learning and AI. And I think it's important for people to think about what can we do about this? Because at the end of the day, when you talk about technology, centralization of power gives maybe the best utility to people, but doesn't necessarily over the lifetime gives the best equal access to people. So that was a little bit the big contradiction of today's talk, right? The research and the community and the software is open. Everyone has access to it. Everybody here who wants to invest the time and has the abilities is able to get into this area. But getting access to the data or getting access to the computational power might not be as equal as everyone else. So how do you deal with that? In my opinion, and this is very much an opinion because as a startup we do this, you find an area of data and research that no one really cares about initially. Right? Everybody, if you're Google, you care about impacting 1 billion people. Right? You care about actually building technology that understands vision. If you're Tesla, you want to put 1 billion cars on the road. But on the other hand, so you care about vision, there's companies that care about language, but there's a lot of data sets that a lot of these big companies probably won't be going after. Right? There's things that are happening in the medicine space that are very specific. In our case, trying to understand the source code of the world is something that can have a very big impact, but is something people aren't focused on today. So find your area of research, and make your pitch deck that says artificial intelligence, that I think 9 out of 10 pitch decks say today, and go out and try to find your data set, right? And find a way to be able to balance between having open data and having proprietary data. So this is some of the interesting stuff that we spend a lot of time thinking about. We also really just like playing with data. There's some amazing communities around the world that are trying to push this. Data World is a community that's trying to make data sets open and people can check out. GitHub plays a role in this and many other places. So this is a little bit this contradiction of the talk. What I want to do now is maybe just open it up for questions if anybody wants to ask about anything specific. We started a bit early, so we have a little bit of extra time. So, no. I'll repeat it.
You can hear it. So my question would be like you say that very powerful AI is far away. But how, if, like, consider that AI will be like much more intelligent than us, how would we recognize that it exists? Or let's say, how does your dog, let's say like the difference between this AI and us is the difference from you and your dog. How does your dog know that you're not taking him to the park, to the vet,
Yeah.
at all?
So there's this question, which is a very philosophical question that a lot of people like to discuss over lots of drinks in AI, and it's essentially how far is this distance towards general intelligence or super intelligence, and how do we actually know it exists, right? So there's this analogy which is like, how can an ant understand what a human is, right? And if you have super intelligence, we are the ants, right? Just I don't have a great answer. I'm not a philosopher, but there are a few places that I've seen very interesting opinions. So there is a blog called waitbutwhy.com. It's an incredibly interesting blog on many topics. It's an author who spends about 3-4 months researching a post and then writes 1 or 2 posts a quarter. And there's some very interesting things thinking about what does it mean to have super intelligence? What's the impact on the world? But for me, what I caught from some of these discussions is that we have this tendency as humans to, there's a fancy word, anthropomorphize, to be able to look at technology or look at robots or AI and try to project human thinking on top of it. But the reality is, we will build an AI and it will be evil and it will try to conquer the world. And the reality is, it's technology. It probably won't have that same understanding or the way it thinks about the world as humans do. So there's this great thought experiment that says, there's a researcher and he goes and builds an artificial intelligence system. And he doesn't know that he's actually building super intelligence. He kind of stumbles upon it. What he's actually building, he's building a system that says, the output essentially is make paper clips. Right? It says, to the computer, make paper clips. And what happens is he stumbles upon super intelligence. And the main goal of this machine was to make paper clips. So it starts making paper clips. It starts making a lot of paper clips. All of a sudden, it realizes that if it keeps on making paper clips, it needs to use all the resources in the world. It starts stacking so many paper clips, the humans are in the way. It doesn't even think about it. So it just stacks us on top of it. And before we know it, we have a universe full of paper clips, right? And I think this is an interesting thinking that, technology doesn't have this human component. It's not evil or it's not good. At least we haven't figured out consciousness in machines by far, in my opinion. But it might be that we never figure out consciousness in machines. We might never get to this general intelligence where AI is exactly like humans. We might end up jumping to the part where we've just built a system that has one simple goal and ends up, replicating that goal at scale. And in my opinion, we're far away from that because I'm close to the technology. Right? The technology today is very, very dumb compared to what things are doing. Neural networks might be even the completely wrong approach. Right? It's just something that works very well for detecting patterns in data and things like that. But it might have nothing to do with what in the end maybe one day becomes artificial intelligence. But there's a lot more smarter people. There's a philosopher called, I believe, Nick Bostrom, who likes to think about this. He's quite apocalyptic. There's Ray Kurzweil, the singularity and these kind of things. So if you're interested in that, it's great dinner talk. Any more questions?
Do you know any resources about datasets which are similar to GitHub, but tailored for data scientists and for developers?
So sorry?
Not for developers, but more
In other areas.
you know,
Yeah. So the question is, it's actually a question one of our senior machine learning engineers is talking later, is do you know of any other data sets that are interesting for developers and data scientists out there, with the exception of code, which is the one that we use because we like to be the one that figures that out. To be honest, for me, there's something that I personally find very interesting, and that is art and style and design. We have huge amounts of portfolios of work out there from people, both designers and artists, and you can build a lot of understanding around that. You can build around creativity. I think there's a lot of interesting data sets in genetics. I know very, very little about genomics, but at the end of the day, we're now just getting to the point where we have millions of people's genomes sequenced, and we haven't really built a lot of understanding of what's happening in our body. I think there's a lot of interesting companies thinking about this. Research papers, right? There's a huge amount of research online in research papers, and a lot of scientists, a lot of people have been working on a very narrow area of research and stumbling upon things that they never consider might be relevant in another field, right? Some of the most interesting things we've come across in medicine were just accidents, right? The right people talking, figure out, hey, this, I don't know, Viagra, you know, this was supposed to be heart medicine, or penicillin, or all of these kind of things that just stumbled out of it. There's been so many experiments and so much research done that I've seen some companies are trying to say, like, look, what if we could build an understanding of that, right? A machine that is able to consume all of the research in the world and connect the links. So I think there's a lot of these data sets. I think there's also some companies that just have private data that can be very scary, right? If you're a bank, you know a lot about your people. If you're a telecommunications company, you see all the traffic that moves through your network. These are the kind of data sets that these companies have access to, where deep learning is incredibly well to apply to, right? But might build understandings of people that come up in ethical situations, right? Would you give a mortgage to somebody who your deep learning algorithm says isn't responsible in spending? Actually, for that, you don't even need deep learning. You can use pretty basic statistics, right? And these are the things that we're starting to think about. Actually, we were talking over breakfast that in China, they're considering using a rating system. It's right now a discussion in politics for people. That is a rating system that can be used in anything, right? In your healthcare plan, all these things. So I think there's a lot of scary things that are happening in this area. And we need to be careful with our own data that we're willing to give away. But what's kind of so far technology has shown is that if it gives us utility, we are very easy to give our data away. Right? We're very easy to give it to Facebook if it connects us to our friends, or if anybody has seen their search history in Google, right? We do it because it allows us to get results. So this is, for me, I think, a kind of scary topic, but I'm also a little bit of a weird privacy kind of guy, so I might be a little bit too far out for these things. Yeah.
Mikko, you were talking about superintelligence a few months ago, and about that we should try to de-anthropomorphize it. And do you know if anybody who would have done the same for humanity and considered humanity as kind of superintelligence that has resolved, and whether we could analyze where humanity as intelligence is going as a whole?
So it's a super interesting question from Mikko, just essentially saying, is there a way that we can actually understand human intelligence and understand where it's going, right? Because we've come from essentially, being in caves and drawing on the walls to where we are today. And it also feels to us that we are kind of on an exponential curve, right? If you look at the world in terms of like how much we've progressed and what the impact is that we're having on, the amount of people that are, having a longer lifespan, all these things, it almost feels like we're on this tangent of an exponential curve in terms of how we're evolving as humans. I think that might be a little bit arrogant in my opinion, because I think probably the same guys who were doing the, the steam engine revolution were thinking the same thing, and probably when we were cutting out of the caves and making fire, we thought the same thing. But it does feel a bit like that. Can we build an understanding of human intelligence? Personally, and this is very personal because I'm also not an expert on this, is that today neural networks and the technologies we use are fancy statistical models. They really are, right? They are essentially activating neurons based on samples. And I think our human consciousness is far more complex than that. I think our own intelligence is far more complex than that. And I also think humans are too far imperfect to try to apply such a perfect model to it. So I really have no clue. But I think it would be amazing if more and more people are thinking about this, right? Because at the end of the day, understanding ourselves better and understanding our intelligence and these kind of things makes us more tolerant. Right? Makes us more tolerant in the world, because the more we can show that we're equal and that intelligence or these kind of things come, they grow in society, the less we start caring about where we're born or where we went to school, or we start thinking more around education should be access to all. I mean, we're in Finland, right? I'm from the Netherlands. They're kind of the common topics. But so I think there's some interesting things in the parallel with advancing in technological understanding of humans with what actually can make us more tolerant in society. But I need a few bottles of wine to maybe really start getting interesting about this. We have 1 more minute. Any more questions? No? Well then, thank you very much.